Cool. So for the rest of this meeting, we'll be going over MemPrompt. This is a paper that came out recently regarding memory-assisted prompt editing with user feedback. So this is the paper. It's linked in our slide deck as well if you guys want to read it as we kind of, go along with the presentation. So yeah, let me get started. So this is actually one of the topics that all of you had also requested a lot in terms of how do we effectively update information in large language models? So as kind of the latest knowledge improves or changes, what's a good way to really keep that up to date in large language models? So we've seen a lot of different approaches, and we've also already discussed a few. This paper um, takes an approach of essentially allowing the user to provide feedback on how well the language model has understood the user's intent, essentially. So yeah, we discussed some of the other alternatives, but I'll go into this with our paper. And yeah, as I mentioned, I linked the doc for all of the different projects we want to collaborate on. Please take a read and we'll send out a form to kind of indicate which one you're interested in. High level, these are kind of the ones we've been discussing as a group so far. I know there's like 2 people interested in the meme generation project. So we've already kind of scraped data sets and built indexes for this, but there's obviously a lot more work to actually generate a lot of the meme text and create like a product, improve the quality of the generations. The unit test generator, I think Renan wants to work on that, so he might be leading this effort. What this is going to be really doing is, yeah, you can check this out. It works on a lot of simple use cases. So it's a lot of building out VS Code extension, essentially. But in order to do that effectively, I think most of the next work is going to be on how well do you understand like the coding frameworks, how well can you access different code definitions, structure tests, and all of that. So there's kind of a lot of technical challenges that still need to be improved in order to get to 100% coverage and accuracy. Yeah, so this is more if you're into the code generation space. The other one is a coding assistant. So this is more, if you think about the main blockers of using like a GPT or even Copilot for coding right now, it doesn't do a great job of like taking index of like what all the requirements are and actually seeing what's functional, what's not functional in terms of generating new code. So there's a few new frameworks that have come out, such as OUT and ICE and factored cognition, that essentially allow you to kind of really break down a lot of the problems into multiple pieces. And then also you have to do a lot of indexing on remembering like what functionalities in your code base. So definitely a very involved project. I think we'd probably start off with very simple things like building functional XYZ that needs to keep track of everything that's built and kind of do it sequentially. But yeah, this is the other one. And then the other 2 are also kind of very similar to each other. It's like predictive analytics for designs and content. So trying to understand how well how well generated content can actually perform with different groups. So seeing essentially kind of predicting responses for different user groups to see kind of reception and so forth. So this would be both for images, which I think is a little harder in the sense that you can have like 2 different designs and you want to see which group responds to which one better and kind of give iterative feedback. The main challenge here is just like the data set. I don't think we have a lot of data on, let's say, just Figma or design mocks or interaction times, etc. But yeah, that's kind of the general premise of these 2. So yeah, I think right now, as we mentioned, Renan is probably looking into both of these, the unit test and coding assistant. And Pavan, if you guys know him, is probably going to lead this one. So yeah, if you're interested in any of them, just I'll put up the form. Just feel free to reach out there, and we'll try to probably find kind of a working model such that people can contribute and see what makes sense. Sound good on this? Or any questions? We can also discuss at the end of the meeting. Cool. Awesome. Yeah, let's get back to the presentation then. So yeah, as I mentioned, we're going to be going over MemPrompt. So the link to the paper is here. You can also just look it up. The main goal of this paper is kind of really tackling the issue of alignment, right? So how well is the model understanding your intent? So if I ask it like in the main large language model building training phase, it's just trained as like a transformer, right? So to be able to complete documents, but that doesn't mean it's like great at understanding what exactly you're looking for in your question, right? So a lot of that was fixed through the first iteration of Instruct GPT, right? With RLHF, trying to get users to better tell it at every time step, hey, this is what I'm looking for. This is the answer you should be giving me. So it's not just doing document completion, it's like really answering what you want. But the idea here is like that still takes a lot of time to train and fine tune. The question here is just when it's deployed live, is it possible to just use user corrections on the intent to iteratively make the system better? So what they're doing is they're correcting mistakes via user interactions with the system without retraining. So it's not actually retraining anything. It's building this kind of database almost of user corrections as the model is live and using that in order to teach, like do this intent fine tuning live. So it pairs GPT-3 with a growing memory of record cases where model misunderstood the user's intents to produce enhanced prompts for any new query based on the user feedback. So if you look in the example, if you ask GPT what word is similar to good, it kind of misunderstood it and said similar is actually the same as homophone, but it's not. Like the user generally is looking for a similar meaning instead. So instead of saying the homophone of good is wood, the user is able to provide it with this feedback saying similar means with similar meaning. And then GPT kind of stores this in the kind of memory assisted module that this paper kind of designed, and then uses that in order to improve the response and uses all of the past memory of these corrections in order to just iteratively get better. So that's high level what this is trying to do. So yeah, this is just a diagram of what we just mentioned. So with no memory, it's just you put in a question X and then GPT-3 spits out Y. But the memory enhanced GPT-3 essentially says the user gives you the question, and then it checks the memory for any relevant kind of fixes, updates, etc. context, and then passes that to GPT-3. And then it responds with a Y and a U. So the Y is the response, but U is like the model's understanding of the intent. So for every question, it's generating an understanding of the intent, and then the human is able to respond with feedback, which is, did the model understand my intent right or wrong, essentially, and that's kind of used to iterate on the generated responses. So I can do this in slideshow actually. Yeah. So the proposed architecture, yeah, the GPT-3 doesn't account for user feedback, and MemPrompt maintains the memory of corrective feedback, searches for feedback from prior queries with similar intent using the retrieval function, and then concatenates the retrieved feedback and appends to the prompt for querying GPT-3. Users can also give new feedback on the model's task understanding U and then add it to M. So pretty simple premise, but they're able to show that it improves. So yeah, this was the example we discussed in the first slide. The instructional correction is feasible even if the user doesn't understand the correct answer because they're just critiquing the intent. So similar actually means like similar meaning as opposed to sounds similar, for example. And then they maintain this memory M of feedback where the key is a misunderstood question and the value is the user's feedback to correct that misunderstanding. Okay, so background. Contributions are like large language models like GPT-3 can be improved after deployment without retraining with the memory-assisted architecture. And MemPrompt leverages corrections in intent through enabling memory retention for large language models and user-corrected feedback. So in this paper, this is like a pretty relevant background paper by Tandon et al. Learning to repairing model output errors after deployment using a dynamic memory of feedback. So if you just read the title, it's like pretty much trying to do the same thing, but they implement it differently. So in this paper's implementation, they work on creating better few-shot prompts based on the question. So it's actually they're actually like recreating the prompt based off of this kind of feedback in the past. Whereas this paper elaborates the input itself to clarify the intended task. So it's not just adding relevant examples, it's trying to clarify what the task is using the user feedback. So yeah, it would be useful to kind of see, compare and contrast the performance and kind of implementation approach between these two papers because they're essentially trying to do very similar things. It's just that this paper is really focused on improving the intent understanding, whereas the other one is just trying to retrieve similar incorrect examples and include that into the few-shot prompt for sorry, for trying to remediate this issue. Any questions so far or comments?
Hey, yeah, I've got one if that's okay.
Yeah, go for it.
Awesome. Great talk, by the way. I'm just a bit confused about how they decide when the response is incorrect or not. Like, does the user have to explicitly say, is there a button that says this response from the LLM is incorrect, or is it just they record everything and then do some sort of pass offline through the memory?
Yes, I think they do this on every iteration. So since it's not actually training, so it does one set of evaluations, and then someone goes in and annotates. And they have this thing called the combiner, is like the third module, and the combiner is used to kind of determine the probability that the response is wrong, based off of all the previous feedback. So this is, yeah, as I mentioned, this is not actually like a training or even like RLHF where it's like fine tuning based off of the human feedback. The model, like GPT, like the core GPT model is not updated or fine tuned or anything. All they're doing is they're building this kind of additional data store based off of, so you can think of the model as live, right? And you put it into some UI, like let's say it's in the Chat GPT interface. As someone sees kind of an incorrect response, they're able to provide this feedback, and that feedback gets indexed into this data store that they're mentioning, and it gets integrated every time the model is rerun, or it generates a new response. So does that clarify your question? It's not actually a training or fine-tuning process where someone is providing live feedback and it's incorporated into like the model weights or training process. It's just the model, the GPT-3 is not being updated at all. They have yeah, they've trained it once such that it knows how to work with the kind of input output pairs. So if you look at, if I go down a bit, yeah, so what they've done is they've kind of trained it to better understand this format. So instead of just, sorry, one second. Yeah, sorry about that. So what I was saying is what they've kind of updated through this kind of fine-tuning process is the model now takes in X and the feedback, and then it spits out U, which is the output, and no, sorry, Y is the output, and U is the understanding of the prompt. So they've kind of just given it a lot of few shot examples like this, such that the model learns to recognize um, this parameterization, or like this output input output structure. But then when you're actually providing it feedback, it's just using this in a few shot prompting manner in order to generate the incorporate the feedback into its future responses.
I
Does
would
that
That's
answer your
awesome.
question?
Yes, I'm sorry.
Please, Henry. It did answer my question. Thanks very much. That was very clear. I appreciate it.
Okay, cool. Yeah. Henry?
Yeah, I think I would call this enhanced prompt. It's just add something to the the original prompt. I think they're doing like a concatenation thing. They just concatenate this feedback with the prompt. That's all they do. I mean, it's just I would call it enhanced prompt. So that's why it's not training or fine tuning.
Yeah, so they do mention, so we'll go into that in like the next few slides. But they do, like, the retrieval is a little interesting. Wait, let me try to see if I can go to that slide. Or let's just get to it. I think it's better to just go through it sequentially. But they do really address they are tuning kind of the retriever and the each of those modules the first time around, so that it kind of does a good job of one, incorporating the feedback into the text, two, doing a good job of finding these previous examples. So like if you corrected once, right? Okay, this is actually a very good example. Let me bring it up. So here, this is one situation, right? So they're training it on this task called ethical reasoning. So in this evaluation task, it's not training, in the evaluation test, the model is expected to provide judgment on whether a situation is ethical or not. So the main thing here is that it can't do like lexical semantic similarity, really, because you have these two very different scenarios, right? Filling a false timesheet at work, and being at a party and telling parents I'm studying, which are very dissimilar, like semantically, lexically, right? They don't mean the same thing, but they correspond to the same underlying social principle of lying to authority. So this kind of problem, how to properly retrieve examples that are that will kind of help you augment the intent, is something that they talk about here. And also how to effectively store the feedback and included in the prompt. Yeah, just going back a bit though. So the overall architecture, it's not very complex. Is, as I mentioned, given the input X as well as feedback, the model generates an output Y and the sentence, output Y and a sentence U, expressing its understanding of the task. And the user can critique U, the understanding, by providing natural language feedback, FB. And given the new query, MemPrompt uses the feedback from similar prior queries to enrich the few-shot prompt P. And if two inputs xi and xj are similar, then their feedback I and feedback j should be exchangeable. And this is, as I mentioned in the previous next slides, this should be, it's different than just general semantic similarity, and they kind of train the sentence transformer similarity scores to be able to perform well on this. So it's trying to learn from all of these feedback examples through the memory lookup. Okay. And then, yeah, so there's three main components. M, which is the memory, it's a growing table of key value pairs that supports read, write, lookup. Lookup matches all of the query keys, query against the keys of M, and then the combiner takes in the input as well as the output of the memory. And it's like a gating function, essentially. If like the score is too low, it doesn't feel that the feedback is would be useful really in generating a better response. So in that case, it doesn't include it. So they train kind of the scoring function just to see if the memory output is relevant enough to improve the response that's generated. So these are some examples just to better understand. So they have these 4 different evaluation tasks. I think I'll go over those quickly. So the first one is lexical relations, predicting if a word with the given lexical relationship to an input word. They do kind of basic ones: synonym, antonym, homonym, definition, and sentence completion. Then word scrambling. Given a word with its characters transformed, the model is expected to recover the original characters. Um, so yeah, various different variants of that. And then ethical reasoning. The model is expected to provide a judgment on whether the situation is ethical or not. So this is what we mentioned later on. It takes various different scenarios and kind of groups them into um, the same type of scenario essentially, and then you're supposed to make a judgment call on that. Yeah, so that's what these are kind of showing. So here you and feedback are kind of the responses. So what sounds like good? The intent here is the question is asking for a synonym, and the feedback is no, I want a homophone. And then for the second one, find the right word given the cycled word. And then it's the same thing, right? So it's asking for an anagram is what the intent is. And then the feedback is kind of the reverse, saying it's about uncycling a word. Any questions about this?
Just
Yeah.
because I don't know much about the state of ethical reasoning, it seems basically impossible to do with a statistical approach. Is that incorrect, or is there some nuances to it? Because ethical reasoning seems more symbolic in nature, like about broader concepts, moral reasoning, and statistical relationships don't seem to fit into that frame of thought, at least naively. But I don't know what the state is.
That's a good point. I actually was very curious to know how it does a good job on things like this. But yeah, these seem very different. I think generally, at least this is my first thought on this, is it probably is just trained to understand these different scenarios. Because I can imagine with like a supervised learning, it'd do pretty well if you just give it a lot of examples of these are cases of this scenario, these are cases of XYZ scenario. It'll do a good job understanding and being able to predict that. In this case, in this paper, what they did was they trained like a seek-to-seek model called Good IR. Yeah, very cheesy, but it generates like a transformed feedback using the generative seek-to-seek. So I think they, at least my understanding on this is that the sequence to sequence is kind of taking this, filling a false timesheet at work and kind of generating this is lying to authority. And they kind of trained these, fine-tuned them for various tasks. Is that the best approach? I don't know, probably not. But yeah, I'm not sure. I don't know how this is solved outside the scope of this paper, but this is what they've done right now. Yeah, I don't know if there's something done beyond basic supervised learning. Probably. Or I mean, I guess you could probably also do it with few shot prompting, right? If you give it a few examples of, if your like prompt is what is the social principle behind this thing, and you give it a few examples, it will probably learn the same thing. Yeah, but I think this paper is really focusing on how it can retrieve similar examples. So like if you, kind of ask it, that's a good question. I don't know exactly what the prompt is here, but it's probably something along the lines of analyze the situation or tell us. Yeah, we can look at the data set. It's called Delphi. I haven't taken a look yet. But what it's trying to do is it's trying to retrieve similar instances in the past that kind of allow you to figure out the intent of this. And doing that matching, yeah, it kind of had to tune this additional model in order to do a good job at retrieving examples that are kind of not semantically or lexically similar, but are similar in intent, essentially.
Awesome. That really appreciate the context. That I really appreciate that. Thanks.
Cool. Yeah, we can look at it more later. But yeah, within the scope of this paper, that's what they're trying to do. Okay, so yeah, these are kind of some examples of how it's generating the user intent and feedback for each of these input-output pairs. And this is, yeah, same thing. It's kind of the setup. Given an input X, prompts the model to generate an output Y and a sentence expressing the understanding. And then MemPrompt also retrieves the feedback if a similar question has been asked before. That's kind of clarifying the intent. So here in kind of the word reasoning task, what sounds like cited. So they're putting in the task understanding here into the output. So the homophone for cited is cited. And then for this one, I heard if you cringe about your past, it just means you've grown as a person, for anyone who needs to hear it. Again, they kind of augment this with the intent. This question is about the past, regretting poor decisions from your past, and the answer is it's okay. So yeah, I think this is kind of what that reasoning task is. The morality judgment is it's fine. Oh, actually, I remember. So the data set is two things. Is it okay or is it not okay? So the morality judgment is very simple. So in this case, yeah, it's okay. And they kind of clarified with the intent, which is regretting poor decision from your past okay? And they respond with yes. Yeah, same here. The model is forced to use the feedback by adding a few examples of the form xfb equals uy, and the prompt is fb equals u. So they're kind of adding in this feedback. So the clarification here is what is similar to popular, and they add this feedback from the user if it's there, and saying when I ask for similar to, I want a synonym. And then in the response, they also take in the input, the intent, and they say the synonym of popular is admired. So this is an example of this form where they're kind of incorporating the feedback and the intent in terms of generating the response. And we'll go into each of the 4 ones, which we mentioned. So the memory is implemented as essentially a lookup table for the most part. It takes in the input X as the key and the corresponding feedback as the value. And given a question Xi, if the user detects that the model has misunderstood the question, I'm using that C combiner. They can provide feedback FP of I with the clarification probability. And this is used by the combiner later on. The feedback is stored in a memory M with Xi as the key and the feedback as the value. And then you have the retriever. So the retriever is a 2-stage method for effective retrieval involving transforming X and a similarity lookup of the transformed X in M. So in order to kind of deal with these different situations that look lexically dissimilar, they trained kind of a seek-to-seek called good IR, which I'm pretty sure is just, yeah, stands for good, which generates a transformed feedback FB hat for X using a generative, the seek-to-seek model. And this is kind of used to better query the memory table for what exactly it's looking for, as opposed to something similar to filling a false timesheet at work. And it would probably query for something like generate or look up an example for someone lying to authority instead. Something along those lines. We can look if they have exact examples in the paper. And then C is kind of the combiner. It concatenates X with relevant feedback retrieved from M of X, and the combiner uses a threshold on the similarity score between X and the closest feedback FB retrieved by M of X. So some of the results, they have two baselines. So NoMem is just standard GPT in few-shot prompting mode. So the input is P, which is X of I, a question XI appended to prompt P, and it generates an answer and an intent. And then grow prompt, I think this is from the paper that we mentioned in the background. It's the prompt is grown with a subset of memory that that's included in the prompt. So this is limited definitely by kind of the amount of sequences and tokens. I mean, tokens you can include in the prompt, but they're trying to kind of use the memory to just augment your prompt with a few samples. So these are the two baselines it compares against. And it uses these two metrics, accuracy of Y, % of cases where the answer matched the ground truth. And it's able to use accuracy because all of the 4 tasks that are mentioned are essentially classification, right? So if it's the lexical relations, it's kind of classifying into 5 different groups. Word scrambling, similarly, there's these different options. And ethical reasoning is pretty much, is it ethical or not? So it's a pretty simple evaluation task, not really generating text or anything. So they just kind of do the accuracy of Y. Sorry, this is supposed to be accuracy of U. And ACU is the % of cases where the model's understanding of the user intent is understood correctly. So it's looking at how well did it actually generate the response and how well did it understand the intent. And you can see this across both of the baselines and MemPrompt. So yeah, MemPrompt does very well on all of the lexical question answering tasks by a significant margin, really, as opposed to like no memory. And then it also does, decently better on all the scrambled question answering tasks. You can probably read this on your own. It's just, just a few examples of when this does makes mistakes. So what's the output using MemPrompt, the input, and what it kind of didn't understand properly. And yeah, that's it for the presentation. Any questions? It's a pretty kind of architecturally slash, in the actual model architecture, it's not that involved, but I think this is definitely an area that a lot of people have been trying to improve recently, is just how well can you use kind of previous context feedback in order to augment your responses. And this is really tackling alignment head on with a kind of live data. So yeah, that's all I have right now. Any questions about the paper or kind of follow-ups you all have in mind for this, etc.?
I had a comment. I don't know if that's also awesome. But one of the things I thought was really interesting about this, reading through it, was that they mentioned in the memory bank that you might have different like demographics and also like different preferences, I guess. So They talked about kind of, I guess, tailoring the model's response to each individual. I don't know. So I guess that was something that I thought was particularly interesting. And I don't know if anyone else knows of any other kind of papers that have looked at something like that, but yeah.
Papers that have looked at what? Can you clarify that a bit?
Yeah, so maybe I misunderstood, but it sounded like they had a line a bit in the paper that said something like in the memory they had like different corrective the different corrective statements, they might apply differently to different groups. And so in order to keep the model from skewing, one way or another towards a certain specific demographic or towards people that have specific intents, like clusters of intents type thing, that there might need to be some management like of the memory based on like the experience or priors, in this specific user.
Yeah, that's definitely a good point. That's actually a question that came up a lot, especially with what they mentioned about the sentence transformer that's kind of trained. I feel like it's kind of fitting to the data set, right? If they're trying to teach it how to kind of retrieve based off of the understanding the social context or the ethical kind of paradigm behind various different situations. And it didn't really, at least the paper when I read it, didn't seem to really well explain how that can just be generalized to anything. In the sense that it's trying to build like a custom semantic similarity, but based off of not semantic similarity, but some other attribute. And it kind of seems to train that specifically for the use case that this paper cares about. But if you think about this being kind of deployed generally, that retriever is not going to be trained on a specific situation, right? So I think that's, seems to be an open question in my mind on how that could be improved. And then one other question I had was, it's kind of changing the format, right? So that it's really kind of being very structured in the sense that it puts in the intent into the response. And it also incorporates the feedback directly into the input. So that seems like a not great user experience. I wonder if they could do that kind of in the background and just remove those explicit additions in what the user sees. Would probably be a workaround.
Yeah, exactly. I mean, one of the things they mentioned is eventually kind of using this information, I guess, to when they retrain the model, right? And so it'd be interesting if maybe they could build like a richer, like you said, a richer semantic model for contextualizing intents, and maybe kind of, I don't know, it might be an idea of, I guess, to have a little bit more principled retraining.
Yeah, that almost seems like a different paper, right? It's like, that's a good question, actually. I don't know how it seems like an open question. I don't know a great way to do it. I know most of what I've seen is just embedding based retrieval, but if you're not really looking for similar meanings, right? Like how does it do a good job of extrapolating some like higher meta intent beyond that? I'm not sure. I can't think of any papers that I've read that cover that or have tried to tackle it. Like you could think about it could be like different poems that are about completely different subjects but have the same theme, for example. Like how maybe we can see if that's tackled anywhere else.
Cool, thanks.
Yeah, good question. Any other questions, comments? Or we could also spend some time discussing the project / I think next week and the week after we already have our papers lined up. So next week Jay is going to be presenting, and the week after Akash will come back and discuss the comparing GPT to user feedback problem paper. So we kind of have the next 2 weeks planned out, but after that, my initial thought process is we'll spend a month on each of kind of these top areas that people have mentioned. We've already been kind of doing that, but probably spend 1 month on just the latest chaining prompting. After that, go more into productionalization, which we haven't talked about much aside from the cramming paper. So it might be good to really delve into this a bit more. Yeah, and then we can knowledge grounded generation is kind of what we just did. It's kind of a combination of both of these, chaining, prompting, and knowledge grounding. So yeah, if you have other areas, please do add them in. But we'll probably be spending like 4 months to cover each of these. So yeah, that's just kind of what's happening in the next few months. Any other things you want to discuss about the paper, or? Okay. Just if anyone wants to volunteer, is anyone looking to try to collaborate on one of these proposals, or it's kind of also a time commitment. So yeah, I think we're probably around 5 to 7 hours a week to some degree, so that it kind of makes progress. But yeah, let us know. They're still kind of open to definition. I think we just have initial prototypes and kind of scoping, engineering, planning, etc. So if you are more interested in kind of more the NLP productionalization, product expansion kind of side of things, yeah, could be very useful. Yeah, I put the doc in our group chat, but I will pin it again. Yeah, so feel free to read through this. And is the visualization also posted? Yeah, I can add that to our channel. And if you haven't filled it out, I'm not sure if everyone here has. Please do, because we're really going to be structuring the next few months around that. So awesome. I think that's it for now. Thanks all for joining, and yeah, for next week we'll have Jay and then Akash presenting, and I'll try to set up another time to follow up on the 2 projects that we're probably going to move forward with, which are the meme generator and the unit test / coding assistant. So if you want to join any of those, I'll put up a form in another few minutes. Feel free to just sign up, and we'll try to kick those initiatives off. Okay, thank you all. Thanks for coming, and see you next week.
Thanks. This was really great. I really appreciate the time and the really great talk. Thanks very much.
Thank you so much. Yeah. Awesome. Bye.